So my fourth year engineering students have designed for me this testing setup where we can test the friction in the key wheel tread pattern and see how we can improve it for next year. And in addition to this setup where we can drag the tire across a surface, they have actually also designed an artificial salt surface right here that simulates the salt surface at Lake Gärda, where we're going to race again next year. But the problem is this thing has to move at a specific speed in a very controlled manner. We spent all of yesterday trying to program an Arduino to do this job, and for some reason we just can't get it to work. So we blew up 2 Arduino boards, 1 power supply, and we still can't get it to work. We are not sure what we're doing wrong. So in a desperate attempt to fix this, I thought, well actually Bill thought, and I'm gonna do it, if this poor discarded 3D printer doesn't print right, but still actually fully works, can be used to drag this thing across that salt surface. So let's see how it goes. So I have a tiny little program here, looks like this. This is G-code, which is what controls a 3D printer. And here I have the Tronxy printer, which didn't really work as well as we had hoped. So this code is loaded on the SD card. Let's see if it works. So we're just pretending we are 3D printing, but instead of a real print, there's actually just a little snippet of code. And there we go. It is moving, and this motor is moving, which means something like this we could use to run that test setup. Isn't that amazing? I just love engineering, what can I say? So the whole point of this exercise was to control speed exactly, speed and distance and motion, so we can do this test on the salt surface. So I added a little bit to my code. The first one was great, but it only works in one direction and it only has a specific speed. So I just added another little line of code here. So instead of just going to one position, I wanted to go to one position at a certain speed and then back to 0, 0 at a slower speed. So let's see how that works. So let's just start this code again. So we want to print from an SD, and then we have the EVA code instead. Let's try that. So this is what it did with the first little code snippet. Goes to a position 200, 200, and then it reads line 2 in our code, and it goes back to the same position at half the speed. And clearly, we can now control this little motor exactly as we want, just using the 3D printer control board. So all I have to do now is actually just to remove this motor from the 3D printer and install it into this test setup. And then maybe all these problems are solved. Okay, so a little bit of quick surgery, and the motor is now taken off. Used to be up here, and now it's loose. But the printer doesn't know this. The printer thinks its motors are exactly where they're supposed to be, because printers don't really think. They're just robots running simple codes. So let's try this again. Let's see if we try to print this again. So print from SD, we're running our EVA code. And as you can see, the carriage doesn't work, doesn't move, because the motor is here, but it does exactly what we told it. It's spinning fast in one direction and then spinning slow in the other direction. And what it does, it thinks it's moving its carriage from 0, 0 to 200 and back, 200 to 200 and back, but it isn't, it's just spinning in the air. And this is great news because it means that all the motion we need to have for this tire testing experiment, we just had to figure out a clever way of writing the code so the 3D printer thinks it's moving its carriage, but it's really moving our test setup exactly as we want it. So I'm super excited because it looks like everything will work and we get some good use of this poor 3D printer. I felt really bad for it. I purchased it, I selected it, and it just never really delivered. So I'm so happy its heart and soul can actually be used for something else. Okay, so here is the moment of truth. I have installed the motor. Well, okay, it needs a couple more screws, but here's the holder that will hold the motor in the actual test setup. Here is the tire And let's see if this actually works. So let's run this code. Let's print from SD card, run the EVA code, and let's take a look at that motor. Well, there it is. It spins in one direction, and then it spins in the other direction. And in about a week or so, that motor will pull this test setup over the salt surface. The exact distance and speed, I will leave that to my students to figure out, and to write the final code. It will just take them a few minutes to do that. So this is also the moment I realized I filmed this whole video in portrait format. I should have been in landscape. Sorry about that. Too used to Instagram story stuff. You have to survive with it in portrait. Next time I will try to remember to turn the phone and do landscape. But I'm super happy. This takes me a little bit closer to Green Envy and Green Envy's success, because this is a way we can evaluate tread patterns without actually having to take the whole vehicle to the salt flats. And also, in addition to fixing this setup, yesterday I cast a test section of polyurethane like this. This is an easier resin to deal with, which my students will use when they're trying to find a better tread pattern for me, so I can go even faster. So lots of things going on, and I can't imagine a better evening activity, because engineering is really the coolest thing ever. That's a fact. We'll see you next time.